Hi everyone, this is the WSCC Water Group, and this is our online presentation. So to start with, our background, WSCC Water is a public water and wastewater utility in Maryland that maintains approximately 12,000 miles of buried pipes and large transmission mains to provide essential water and water resource recovery services. Our problem statement is that WSCC Water uses gate valves that need to be completely closed or completely open when they're in use. Complete closure of the gate valves is essential because if the gate valves are a little open when they're supposed to be completely closed, water will run through and erode the gate over time. Currently, WSCC Water has no way to look inside the pipes to visually confirm whether or not these gates are fully closed. WSCC Water tasked us with developing a probing camera that can be inserted into the ports of the pipeline to visually determine whether or not the gate valves are open or closed. There are several conditions that our probe needed to fit. It needs to be able to fit through a 1-inch diameter hole to get into the pipe. It needs to fully seal the pipe while it's being used so that water doesn't spray out. It needs to be able to look at multiple angles of the valve, and it also needs to light up the inside of the pipe while it's in use. At the top of this slide, you can see some initial concepts that we started with on our design. In our prototyping process, we split up between mechanical and electrical design. During our prototyping process, we used CAD models, and we also built our electronics separately so that we could test everything individually and make sure that it worked and that our probe would fit its geometric constraints. Finally, you can see in our testing section that we were able to build a testing rig using the same port valves that WSCC Water uses in their own facilities. By using this port, we were able to confirm that our probe fits through their ports and that it could operate in dark and water-filled environments. On to our final results. We feel that we came up with a solution that met all of our requirements. We were able to make a probe that was self-lit, fit through the port, and has a pressure seal on it. As you can see in the picture, you can see the lights, camera, the seal, and the pressure fitting that go into making our design work. In the future, some things that we would do to clean this up would be to improve on the wiring inside of the pipe so that the design is less delicate and easier to use, and we would also develop a way for the borescope to go in and out of our probe faster and easier. We will now show a demonstration of how our project works. To begin, we attach our pressure seal to the top of the port valve used by WSCC. Here I'm attaching it, and this would establish a fully pressure sealed at the bottom. After that, you would open up the ball valve and push the probe through into the pipe. You can see that our camera is functioning, and even though the picture is not perfectly clear, it's well capable of seeing objects that are nearby and seeing shapes. This level would be more than sufficient to see whether or not a gate valve is open. Now you can also see that we are demonstrating our lights that would illuminate the inside of a dark pipe. To retract the probe, you pull it back up through the ball valve. At this point, you would shut the ball valve on a pressurized pipe, and then you can unscrew the pressure fitting. We struggled with that here, but it would be welded onto a pipe, so there would be no plastic bending.